we living in a black hole? It's a possibility. I'm Ben, this is Physics or Bust. The possibility of us living in a black hole right now is greater than you might expect, because most people, when they think of a black hole, they think of the center of a galaxy or the stars that become black holes because of supernovas, where they're super dense and just sucking everything in really tightly. But the fact is, with black holes, the larger a black hole you get, the less dense the material has to be inside it. So one way to think about this is that the escape velocity of an object, which is the speed of light for objects that would be just outside of a black hole, that kinetic energy has to be equal to potential energy needed to reach infinity. Putting that equation on here, we have 1/2 mv squared with the escape velocity equals g mm over r squared. But this is the mass of the object, so those cancel. And this is the mass of the big object, of the black hole, is what we're looking at. So this escape velocity would be just c, the speed of light. And if we divide both sides by g, we get that m over r equals a constant. Now this constant comes out to 6.71 times 10 to the 26 kilograms per meter. And that's the mass per radius ratio needed to make a black hole. Well, if you double the mass and double the radius, then the density of the material inside doesn't have to be as big. So if we have a black hole this size and we double the radius, keeping in mind that this would be a three-dimensional object here, when you double the radius, you way more than double the mass that would be able to fit in there. So the mass doesn't have to be as dense just by doubling the radius. If you keep going with that, the material inside has to be less and less dense in order for it to still be a black hole. So if we expand that out to the universe, we actually are really, really close to the density of what's needed for the universe to be a black hole. Best estimates of the mass of the universe right now come to 1.5 times 10 to the 53 kilograms, and the radius is 4.4 times 10 to the 26 meters. Well, when you do that calculation, we're at 3.4 times 10 to the 26 kilograms per meter. So we're already on the same order of magnitude, 10 to the 26, for both of these. And this amount, the 1.5 times 10 to the 23 kilograms, is the observable universe. It's also just an estimate. We can't see a large portion of the universe, and who knows, maybe there's a disk of galaxies out there, but it's behind the center of our galaxy, being blocked by the dust in our own galaxy, so we can't see that section of the galaxy. In order for our universe to be in a black hole, the area for this mass doesn't even have to change order of magnitude. It just has to be double, and that's it. And it really makes you wonder, so what else would change about our idea of the universe if we realized that we are actually living in a black hole? Put your thoughts in the comments below. Not being an astrophysicist myself, I do still wonder if what we know about the Big Bang would match up to the formation of a massive black hole all at once. Hope you had fun with this one. I know I did. Don't forget to like and subscribe, and remember, keep asking questions.